Christian. And now we will have Ursin Brunner actually back from last time.
Yeah, thanks a lot.
So the narrative is Christian gave some very thoughtful introduction, even funny. Thank you, Christian. Now we're going to build this up again, right?
I just want to say have a bit of a hard job now.
With real good in Switzerland produced stuff, right?
Exactly.
Thank you, Ursin.
Yeah, thanks for having me back. I was here already last time, and today I'm going to talk a bit about the whole large language model hype, and I try more to explain a bit what's behind the technology and what can we do with it. But I'm very interested in the panel discussion afterwards. I think we've got some very good points. Just quickly, I come from TI&M. We're also, I think, sponsoring the event. We build mainly software, but I'm the head of machine learning. So we do projects in machine learning. For a long time, this was like we train models. And now it's often just we use APIs. But I think we will figure out what we'll do in the end. We're around 15 to 20 engineers, which are really focusing on machine learning projects, and a lot of other software engineers which are focusing on more traditional software projects. But yeah, let's quickly talk about this hype we have right now. I mean, we can take any numbers here. We see like ChatGPT reached 100 million users in 2 months. I mean, that's very impressive. And maybe you can ask yourself, why is that? And I think the only reason is basically a bit of a first contact, you know. All of you are using machine learning all the time when you unlock your phone, whatever. But like a general intelligence in a way we have never used before, or a lot of us have not used before. And ChatGPT was just helpful in a lot of different ways, or still is. And that's why it's such a hype. It's somehow helpful. If it's good or bad, we can talk about, but it's somehow helping people. And let me spend maybe 5 minutes to explain quickly what it is, because we always assume that we know. And maybe a lot in here know a lot better than me, but for all the others, I tried to summarize it a bit. And I think this we already heard before today. So it's these large language models, and ChatGPT is one of them. They're basically just predicting the next word. So you gave them a context, like here, the students open there, and then they predict the next word. And to do that consistently and good, they need to know something about the world. That's the whole magic behind it. Under the hood, we have a neural network architecture called Transformer. Some of you might know it. I heard it before somewhere there. It's an interesting architecture. It's nothing super special. Everyone can learn it in a day. So it's really not super complex. And all of these large language models are using this. So there's no magic in it. It's really, right now, it's more like small tricks and the data. And how do they learn? I think this is also easy to explain. You give them a bunch of text, like really a lot of text. And then you basically give them only a few words and always say, okay, now predict me the next word. So for example, here we start with nothing, and then it needs to predict the next word, which is. And if it does it right, then we kind of reward it positively. Or we don't punish it by loss. And if it does it wrong, we kind of punish it, so it hopefully learns the right thing. That's the whole magic, how this large language model learns. What they learn from is not exactly clear. This was for GPT-3. There we knew at least that the big bunch of it was basically the internet. So we had around 45 terabytes of text data, and a lot of it was the internet. Now for GPT-4 and ChatGPT, which is basically the GPT 3.5 model, we don't know so exactly. We know that they use apparently a lot more proprietary data, which has been curated by humans. Also, maybe interesting, this stuff costs. So, an initial training of GPT-3 costed around 5 million. Now we will most probably be around 10 million threshold. I think this one is interesting. Here we see basically the size of these models. So we used a lot of these word models. They're around 100 to 300 million parameters. So here on the y-axis we have the parameters. It's logarithmic, by the way. And here we have the numbers of years. So basically, we can say every year we have 10 times larger models. We don't know exactly where GPT-4 is in here. We estimate it's around 1 trillion. We can see top right there, Palm, the model of Google, which will be released this month, is around 500 billion parameters. And now we can ask you, but what are you even talking about? What are parameters, and why do they need to be big, these models? So the whole story of scaling these models is that if they become big, we have what we call emergent behaviors. So some things just happen. And we cannot really explain right now why it happens, There's some papers around, but it's really hard to explain why it happens. We can just say it happens. So with 8 billion parameters, we have language understanding. But for example, explaining a joke is only possible when we cross the 100 billion parameter threshold. It sounds really stupid, but I think that's the current state. Don't trust the tree. We can also look at a bit more serious data. This was a paper by Google, 2022. We can, for example, take this plot here to the very left. There was a challenge just doing simple math, so just adding, subtracting 3-digit numbers and multiplying 2-digit numbers. Up until like 70 billion parameters, this model just failed. They're not able to do it at all, so they don't know the concept of calculating or of basic arithmetic. But then at a certain size, they just understand, okay, to be better at predicting the next word, I need to be able to learn basic math. And I think this is important to understand. These emergent behaviors are the reason why these models right now made such a high. Then we come to the last recipe, basically, and this is what we call alignment. So it's one thing to have a powerful model, but it needs to be aligned with humans, otherwise it doesn't help us. And alignment or fine-tuning is the process of kind of making the model more convenient for us humans. So long story short, you can just chat with it and it will always work, you know, and that's just because of the alignment. And here, OpenAI used a lot of cheap labor in third world countries to basically create conversations. They also used then this labor to kind of rate conversations and build models, so they can use reinforcement learning to even more fine-tune these GPT models. So that was very quick. I hope you got the gist. Let's talk about the big players. First of all, the elephant in the room, OpenAI. I mean, we heard already the evil person behind it, Peter Thiel and Elon Musk. I think Elon Musk is not too happy actually about the whole thing happening right now, because he wanted to take it actually over, but he was not allowed. And then we have Sam Altman now, which is also brilliant at marketing mainly, I would say. And it's important to understand that OpenAI made a huge fuss right now, and Microsoft just jumped in, but I mean, this was all coordinated. You know, they knew since last summer this will happen. And now we have OpenAI with GPT-4 coming out. We have Microsoft, which says we're going to introduce all of this in our office. You can just generate your presentations in the future from your Word documents and so on. You don't need to make slideware anymore. You can not take part in calls, and then just summarize everything for you. So this is just perfectly timed, I would say. I think Microsoft right now is really in a good position, and not only because they introduced it into their products, but also they offer it to us as an API through their Azure services. It's hosted in Western Europe, so not really Switzerland, but for a lot of customers, or at least of our customers, this is enough. So they really say critical data going to the Netherlands, that's going to be fine for us. So we will see a lot more applications by using the APIs, I think. One last word about Google. They were for a long time the leader in the AI research. They came up with the transformer architecture and a lot of other cool stuff. And they will also come out this month with one of their powerful APIs or models, which we can reach through an API called Palm. And they will also build a lot of cool products around it. So I would say we should not write off Google here. They got a bit caught on the wrong foot maybe, but they will definitely catch up. So now maybe the most interesting part, what can we do with ChatGPT or with large language models today? We can, and this is the most obvious case, we can kind of build this AI assistant we always dreamed of. You know, we were forced to work with these chatbots, which were really awful for a lot of years. And now we suddenly have a tool that is a lot better than a simple chatbot. What all we need to do is basically we need to fine tune it to a specific case. Let's call it health insurance. And what we need to do then is we need to make all the data of the health insurance available to the model, because it only works that way. So let's say you have all these insurance policies and product details, you need to make it available to the model. And also the customer data, if you want the model to be able to give answers to that. So if you want to ask, okay, how much did I spend for health insurance last year? Then obviously the model needs to know about your bills. And how do you do that? Just a very, very sketchy architecture. You need to make your documents or your data, can also be databases, available in a way that you index it in a search index. Best is kind of a vector-based search index. And then if I ask a question, I'm going to first try to reduce the data to all the things that could potentially have the answer in them. And then I take this and give it to a little robot, which can be GPT-4, can be Palm, can be even a self-hosted LLM. And this one is then hopefully finding the perfect answer or formulating it. We did already something similar in a project for a customer around half a year ago. So this is more like a search and a PDF viewer to the right, and then to the left we have documents. And now we can activate kind of the neural search. And what we can do then is we can really ask a question. And now in the back, so we ask here, wie produziert die neue Bank in Zukunft Strom? And somewhere in these 3 PDFs, there is the answer to that. And what we do now here is we use like traditional language models, and they will figure out, okay, there is this part in one of the paragraphs which answers the question, and then we can give that back. And now if we introduce also, for example, GPT-4 here, we can take multiple responses together and formulate kind of a perfect answer. So that's kind of the whole agreement. Another obvious case is customer communication and analyzing it. I'm not sure if you used Whisper or any of these speech-to-text models recently. They're just insanely good, even in Swiss German. So you can transcribe now phone calls quite easily, automated. And then you can use GPT-4 or any of the cool models to do all kind of stuff. So simple as this, you just want to summarize it and put it in your CRM system. It's already a big deal, you know. Then you have all the summaries of the communication with the customer somewhere. But you can also do customer satisfaction analysis, upselling, cross-selling potential. Or you can also say, maybe we add some value for the customer. And I have here a little example. So we have here GPT-4, and then we have a transcribed call where we talk about Säule 3a. So the customer is asking if he can move Säule 3a because he wants to invest it. And he mentioned some things in this call. And then I basically just tell GPT, you're going to be an assistant and help me here, and I'm going to ask you questions. So I can... I killed it. So, but long story short, I can ask things which are important for me as the company, but I can also ask something that is helpful for the customers. So, for example, here I will ask next, okay, what is the gain you can have if you have a horizon of 20 years? And then GPT-4 will just go through the whole conversation, figure out all the things it needs to know, and then give me a cool answer which I can present to the customer. Okay, now I need to figure out what didn't work. There's some IT experts in the room.
You want to reopen it?
Yeah, I think we need to kill it. I think I will skip the video.
Mm. Mm.
I let it do, and I will just continue. I think there's not too much left. So there's obvious cases like in coding. We are talking a lot about now, the topic of will we become obsolete as software engineers? I think this is not true. We will not become obsolete. What maybe changes how we interact with the code. Maybe we don't write code all the time. It's more like we let it generate and iterate over it. If that's better or not is another question. We did already a few cases where we basically migrated code bases. So, for example, we went from Enzyme, a React testing library, to another React testing library that worked really quite well out of the box. And we also work on like moving really code bases from one language to the other, which is not that trivial, but it will also be a case which is interesting in the future.
I have to reload.
Yeah, no worries. Okay, that will be a few cases. I mean, we work on several cases really right now, but we also feel that our customers, they're right now in the phase where they want to know what is possible. And I think the next phase will be like concrete projects. So we have 1 or 2 concrete projects, but a lot are just in that phase where they want to know what is possible at them.
That's very pity.
How will we use it tomorrow? I mean, we already talked a bit now. The problems we have right now, the biggest one is for sure is hallucinating. So it sounds always good, but it's often just wrong. It's plain wrong. I mean, here's one. This is really the first try. It was completely wrong. But I'm also quite confident that there will be a lot of research in this field. And I'm not 100% sure we can fix it because it's just
intrinsically with how these models are built up, but I'm quite sure we're gonna come up with at least mediocre solution for now. But this will be one of the biggest topics. I think another one a bit more fun is going away from pure question answering to what we call smart agents. So instead of just asking questions, you want to say, take this picture and get me all the ingredients I need to kind of cook it, you know. And this you can do by using basically tools or using APIs. OpenAI created their plugin system where you can build your own plugin, and then if someone says, I want to, I don't know, send money with that API, it will happen. And that's just the first. It's just the first part. It will be possible to interact with your calendar, with your email, all of this. But I think the really big thing is the multimodal part. And you can imagine if you need to explain someone the world, and you have only written text, it's not so much fun. You want to have pictures. You want to have like sensoric. You want to have all this stuff. And so the next big thing will most probably be a multimodal language model. We have it a little bit with GPT-4, which can handle pictures, but that's just popped up on top. This is a paper from Google. It's called Palm E. It can handle different things, so like visual components, text, and then also sensor data from robotics. I'm also not 100% sure yet we are there. But what this paper shows is that you have a positive effect. So if it learns something from the pictures, it's also better than in producing text about it. And if you have that, that's definitely a big thing. What we can do with it is clear, like language is still possible, but we can also, for example, take that picture and ask what meals can I do with it. Then this I think is fun. You can give it that picture and you can ask what the robot will do next, and because it learns somehow something about the world, it can predict that this will fall. Most probably will fall. And here, last slide. I hope it works. Video. So you can give it long horizon tasks. For example, here the long horizon task is bring me the rice chips from the drawer. And then what it does, it chucks it down into smaller tasks. Like, okay, I need to drive to the drawer. I need to open it. I need to kind of get it out. And then if, for example, a mean human comes and kind of disturbs it, and it's gone, then I need to get it out again because it's still not there. And at one point I need to bring it back to the person who asked for it. So the LLM is not directly controlling the robot, but it's breaking down this long horizon goal into smaller chunks. We see that here. So go to the drawers, open them, and so on. And that's just, yeah, it sounds a bit like intelligence. Okay, sorry for technical issues, and thanks a lot for your attention.